Alright, let's start on the equations of ellipses. You want to make sure you get out your notes and go to the page that looks like this. It's the ellipses notes. So we did previously graph ellipses based on the equation, and you can use the equation to get the center and how long the major axis was and how what the minor axis was. And you can get these, and those are A value and that was the B value. What we're doing today and tomorrow, is modules 2 days sort of affair, is we're getting more into ellipses and getting more into the actual definition of it, and then using that to help us write the equation that would describe an ellipse. And so we kind of glossed over this earlier, but the definition of ellipse is it's the set of all points who are, when you add the distance between every point and the two foci here, it's the same all around. So what that means is, in an ellipse, there's 2 points. Each one is called a focus, and the plural focus is foci. So go ahead and explain to your parents while your teacher is saying a really weird word that might sound off-putting. Foci is an actual word we use in mathematics. It's like asymptote, just one of those words that sounds interesting. We're actually going to have asymptotes in a future lesson. But we got 2 foci here, and if you get any point on our ellipse and you figure out how far it is between these foci and that point and add those up, it's going to be the same for every point on the ellipse. So let's say you have a point here, and you get this distance and add those up. It's going to be the same as if you added these 2 distances together. Or you could have a point here on the edge even. This distance here and then this distance, if you were to add those together, would be the same as the original one. So it's the same distance all around. The foci are actually not on the ellipse. They're inside the ellipse. And so those points tend not to be like super useful in graphing by hand because we're not going to go through and calculate these distances and add things up. And I just got rid of it accidentally. But that's what it is. And the foci are a distance that we call c away. We're going to use the letter c to describe how far it is from the center to the focus. We already have our distance from along the major axis here, and that's a. And then we got our distance here, that's b. And then this little distance here is c. And that's going to be important because you'll be using a and b to get c, or use c and a to get b, and there's a relation between them. So if you go to the next part, again, just reviewed that A is along the long part, B is along the short part, and then C is going to be inside. And C and A are always along the same axis. And so if you have a tall ellipse, the focus is going to be along that same axis. It's going to be above your center. Well, if you have A and B and you're trying to get C, or if you have C and A and you're trying to get B, you can use this, what's called a Pythagorean relation. This is not the Pythagorean theorem, which is a squared plus b squared equals c squared. You can use that on right triangles. It's like that, but not the same. And so don't think it's just automatically a squared plus b squared equals c squared. I know math is confusing. We use the same letters in different situations, but you need to know that A and B and C have a relation. You may want to hold on to your notes just to kind of have this. And this equation is going to change based on which conic section we're doing in future lessons. So when we have hyperboles, when we have parabolas, this is going to change. And so be careful with that. But let's go to some examples on your notes and follow along on there so you can kind of grasp this as we go along. So we got this one. We're trying to write the equation in standard form of the ellipse that has foci here. Negative 2, 0, and 2, 0, and then vertices here. We haven't gone over this order, but vertex is it's the a distance away from the center. And so what we're going to do, so using vertices, we can get our a distance, and using our foci, we can get our c distance, and then we can use that to get our b distance and write our equation. We can also use our vertices and foci to get the center. We'll need center, and we'll need the a and b distances to write out our equation. Well, conveniently enough, your center is always the midpoint between your vertices, and it's also the midpoint between the foci. So if you if you have either the foci or the vertices, you can get your center. And it's just a halfway point. On this, it's 0, 0. On future problems, on a lot of your assignments, not at 0, 0. So now that we have our center, we can figure out our A distance. And A is just how far it is from the center to your vertex, one of your vertices, which that distance is 6. And to get C, that's the distance from your center to one of your foci, which in this case is just 2, right? 0, 0 to 2, 0 is 2. 0, 0 to 6, 0 is 6. So we got A and C. We need to now get B. And we're going to use our little Pythagorean relation. So we got that 6 squared equals B squared plus C squared. A is 6, C is 2, so we'll plug this in. And now we need to solve for B squared. So we'll subtract 2 squared, subtract 2 squared, and we'll get B squared is going to be 36 minus 4, so B squared is 32. Now that you have your B squared, you could get B, but you actually don't need it to write out your equation. Because in the equation, if you remember, in the denominator is A squared and B squared. And so you just need the B squared and the A squared. Another important thing to note on this is you do have to make sure if it's horizontal or vertical when you write out your equation, because that lets you know where the A and B values go. Basically, if it's longer vertically, the bigger number goes under Y. If it's longer horizontally, the bigger number goes under X. So you can look at your A squared value, which A squared comes out to be 36. 36 is bigger than 32, and this is along a horizontal distance. So we got a horizontal ellipse here. So we're going to have X squared over 36, that's A squared. And we got Y squared over B squared, which is 32. That's going to equal 1. Since our center is at 0, 0, we don't have to do the X minus something or Y minus something, but in future problems you will. And speaking of future problems, let's look at the next section. So the next section of the notes is the same kind of information, but you have a different center. Your center is not at 0, 0. And so your equation, looks more complicated like we've done previously. And then your foci are still along the same axis as your vertex, but you have to find the center, and then you'll add C or subtract C to get either side of it, or you'll take your center and add the A distance or subtract your A distance to get your vertices there. So let's move on to our examples here. In case you didn't get this example written out, this doesn't equal 1. You have to make it equal 1 by dividing by 16, and you'll get this 4 over 16 reduces to be 1/4, so there's a 4 there. And then you're going to go through and graph your center, which comes out to be -3, 2. Because you got those two values, meaning your center's at -3, 2. And then this is bigger, so that's going to be our A squared, which means A is going to be 4. This is smaller, so that's B squared, and B is going to come out to be 2. So we're going to go right and left 4, and then up and down 2 from our center, and then you can connect those to make your ellipse, looking like that. Your graphs don't have to be great, they just have to look somewhat like an ellipse. All right, so let's move to the one where it's similar to the previous example, but it has a different center. So step 1 is always get your center. So we're going to figure out the halfway point between these. Halfway between -2 and -2 is -2. And then halfway between 1 and 5, well, you do 1 plus 5, divide by 2, you're going to get 3. So there's our center. And if you want, you can check between your vertices. You should end up with -2, 3 again to make sure you got the center there. So now that you have your center, you can get your C distance. C is going to be how far it is between -2, 3 and then -2, 5, which that's just an increase of 2, so C is 2. And then you can use your center and one of your vertices to get A. A is going to come out to be, well, between -2, 3 and -2, 7 is 4. So A is 4, which means A squared is going to be 16, and C squared is going to be 4. And so we're going to use our Pythagorean relation to figure this out, which, remember, is a squared is b squared plus c squared, not the standard Pythagorean theorem. So we're going to have 16 equals b squared plus 4. You're going to subtract 4, and you'll get your b squared value, which comes out to be 12. So we have our center, we have our a squared, we have our b squared, and now we can write out our equation. So you're going to take these 3 bits of information, and you're going to put them in the equation. You're going to do x minus the x value of your center, which is -2. So x minus -2, which is going to be x plus 2 squared. And then we're going to have y minus the y value of our center, which is 3 squared. It's going to equal 1. And then you have to figure out what goes in the denominators here. You do have to figure out if it's a vertical or horizontal ellipse. You can do that by looking at your foci or vertices. Do they change in the y's or do they change in the x's? If they change in the x's, it's a horizontal ellipse. If they change in the y's, it's a vertical ellipse. This is changing in the y's, and so this is a vertical ellipse. So we're going to take our bigger a squared value and put it under y, and then our smaller b squared value, it goes under x. And now you have your equation. And there's your lesson. Hopefully I know it's a little long, but it's complicated. We're spending 2 days on it. So make sure you got it, and I'll do another video that gives you further explanations.